So we're going to introduce this idea of limits. Limits are hugely important. In fact, when you first start learning calculus, it's divided into two parts: derivative calculus and integral calculus. And both the derivative and the integral are defined using this thing called a limit. So the limit, which we're about to introduce, is going to be a part of everything that we do in calculus. It's a concept that affects all of calculus, so we really need to understand it. Now, the good news is the idea of a limit is not very complicated, right? It takes a little bit of practice to kind of wrap your brain around it, but actually calculating limits can take a little getting used to. It can take some practice before you start to get the hang of it. So I'm going to give you a brief introduction here so you can start to understand the basic concept of what a limit is, and then we'll have some videos where you dive into the actual mechanics and details of how to go through and find these different limits. We're going to have a number of different things we call limits. We're going to have limits at infinity, infinite limits, one-sided limits, and those are all, although they're related, they're all different ideas, okay? So let's get into it here. So here we have a green parabola, right? That's our function. And then I have these lines right here to show us for the given point that we're dealing with, this green point, we can see what the x value is, and we can see what the y value is. So basically, when you have a limit, what we're asking ourselves is, when my x values approach a certain value, what are my y values doing? Are my y values approaching a certain value, or is other behavior taking place? So you can see if I move this around here, so I move that point along our curve, you can see that the x value and y value are changing, and we can see, like for instance here, this point, when my x value is 2, the y value is 2. So what happens as we approach 2? As my y values are approaching 2, as my x values are approaching 2, what's happening? Well, my y values are coming down and they're approaching 2, right? And if I approach from this side, as we approach 2 on the x-axis, we're also approaching 2 on the y-axis, okay? So what if we go to a different point? What about up here? Okay, so what we want to look at here is, as my x values are approaching 1, what are my y values doing? So we can see as my x values come in and they're approaching 1 here, my y values are approaching 3, and in fact, they hit 3, okay? On the other side, as my x values are coming in and approaching 1, my y values are approaching 3. Now, coming up shortly, we'll be getting into discontinuities and different ways in which our functions can be discontinuous, and this makes the limits a little bit more complicated. But first, we just kind of want to understand what's going on here. So this picture we're looking at right now, right, where we've got an x value of 1, we've got our function, we've got the point on that function, and then we've got our y value of 3. If we want to look at this in the language of limits, which we're going to be dealing with, would be here. Okay, so let's make sense of this notation, because this is just an algebraic representation of what we were just looking at graphically. So right here, the LIM means limit. Whenever you see limit here, whenever you see LIM, that means we're dealing with the limit. This 1 here, that's our x value. Okay, so you can remember that because look, it says x arrow 1. So the way we say that is we say x goes to 1, or x approaches 1, or x is nearing 1. Basically, we're talking about the x values are getting close to 1, right? So in our limit, we have x values going to 1. The thing that's written right here, this is our function that we're dealing with, right? This is the part that's the function. So whatever function you're working on, that's what you write right here. Now, if it's like a really complicated piecewise function, we might just write the name of the function. So right here, it might just say f of x, and then you would have to refer to whatever version you're dealing with f of x, whether it's a graph or whether it's in function notation or a piecewise function or whatever, you could refer to it that way. But then we're still specifying, oh, we're talking about the limit of f of x as x equals 1. In this case, I just wrote out the function so that you could see that it matches the graph we were just dealing with a minute ago. Then we've got our equal sign, and what goes over here? What is the limit actually equal to? It's the y value. So remember, I specified that when we talk about limits, we're really asking the question, where are our y values going as our x values approach a certain value? So that's what this says. The limit as x goes to this x value, so as x goes to 1, my x's are approaching 1. For this function right here, what's happening to my y values? They're approaching 3. Okay, so normally what would happen is you'd have all this stuff on the left, and you would calculate it, and you would end up with this thing on the right. So if we go back to our picture, we might be able to make a little more sense of this now. Right, so there's our function that we were looking at right there, right? That we had that in our limit. We have the 1 right down here on the x-axis, and then we have the 3 right here. So as our x values are going towards 1, our y values are going towards 3 for this function. Okay, so I'll play around with it again. We can see, yep, as my x values are getting near 1, my y values are getting closer to 3 here. Okay. So we have a few types of figuring out limits for continuous functions is usually pretty straightforward. Where we can get into things that are more complicated is when we have discontinuity. So let's take a look at a problem like that. So this will represent a line with a hole in it. Now, normally if you just go into Desmos and you graph something where there's a line with just a hole poked in it, it's not going to be able to graph that hole. So I've just sort of exaggerated it here so you can see we're dealing with a line with a hole poked in it. So it just doesn't exist there. Okay. So then the question would be, well, what is the limit as x goes to 2 of this function? Well, we can see as our x values go to 2, our y values are doing what? They're coming up and approaching 1. And what if we approach 2 from this side? Well, our y values are coming down and approaching 1. So notice that in this case, the function doesn't even occur at x equals 2. It's undefined right here. There's a hole in it. But the limit still exists, because when we talk about the limit, we're not asking what is the y value when x equals 2. We're saying what do the y values approach when the x values approach 2. And you can see, so what's happening here, right? Let's kind of play the same game. So where are my y values approaching as my x values are approaching 2? So here we're approaching from the right, we're coming down. Well, as my x values are approaching 2, my y values are approaching 1. Now notice that even right here, when x is equal to 2, our function value is not equal to 1 because our function doesn't even exist at x equals 2. But that's not what we care about when we talk about limits. If you talk about function values, then you do care if the function is defined or not. But when we're talking about limits, it doesn't have to be defined at that point. We're asking what happens right around that point. Okay. So you can see if we go from the other side, as my x approaches 2 from this side, my y values are also approaching 1. So in that case, we would say that the limit as x goes to 2 of the function x minus, in this case, we would say that the limit as x goes to 2 of the function y equals x minus 1 is equal to 1, because that's the y values that are being approached as our x values are going to 2. So you can see the limit doesn't care if you're actually defined at that point or not. It doesn't make a difference, which seems a little bit weird at first. Our function isn't even defined there, but we can get that as an answer. Again, we have to make the distinction between when we're dealing with function values and when we're dealing with limits.